Welcome to the Deep Dive Physics, where we like to unpack some of the most fascinating concepts in physics. And today we're going to be diving into the world of quantum computing,
Oh, very nice.
specifically Google's Willow chip.
Okay.
You know, the one that's supposedly so fast it's making scientists question reality itself?
Yeah, it's certainly causing a stir out there, but maybe we should start by kind of separating the hype from the facts.
Yeah.
Have you heard about Willow's record-breaking performance?
Oh, absolutely. Solving a problem in under 5 minutes that would take the world's fastest supercomputers 10 septillion years.
Right.
That's not just a leap forward, it's practically teleportation.
Yeah, it is remarkable, but to really understand why this is such a big deal, we need to step back and look at the fundamentals of quantum computing.
Oh, yeah.
You see, unlike the computer you're probably using right now, which relies on bits, a 0 or a 1,
Right.
quantum computers use qubits, and qubits, thanks to the, quirks of quantum mechanics, can be both 0 and 1 at the same time.
Okay, now let's unpack that a bit, because it sounds like you're saying you can be in two places at once.
Yeah.
How can a qubit be both 0 and 1 simultaneously?
Well, think of it like a spinning coin before it lands. Is it heads or tails?
Right.
It's kind of both in a way until we force it to choose by stopping it.
Hmm.
That's kind of similar to superposition, a core principle in quantum mechanics, and it allows a qubit to explore multiple possibilities at once, giving quantum computers this, massive advantage in processing power.
So that's how Willow achieves such insane speed, by tapping into the superposition thing.
Precisely, and it's not just about speed. Quantum computers leverage another kind of mind-boggling concept called entanglement.
Okay.
Imagine two entangled qubits, no matter how far apart, influencing each other instantaneously.
Right.
Change one, and the other instantly mirrors it.
Hmm.
It's like they have this spooky connection defying our everyday understanding of space and time.
Spooky indeed. Einstein wasn't kidding when he called it spooky action at a distance, was he?
He would.
But this is where things get really intriguing, right? Because some folks are saying Willow's performance hints at something even wilder. The multiverse?
Ah, yes, the multiverse.
Dun dun dun.
Willow's feat has certainly fueled speculation about whether it's somehow accessing information from parallel universes.
Right.
The many worlds interpretation proposed by physicist David Deutsch suggests that every quantum event creates a new universe where every possible outcome exists.
So is Willow potentially crunching numbers? Not just in our universe, but in countless others simultaneously?
Right.
Is that what's giving it this mind-blowing edge?
It's a captivating thought, isn't it? Imagine billions of Willows across billions of universes all working on the same problem, feeding the results back to our reality.
Right.
But it's important to remember that this is just one interpretation.
Yeah.
The more widely accepted Copenhagen interpretation suggests that quantum states are just probabilities collapsing to a single outcome upon measurement with no need for multiple universes.
So it's still up for debate whether Willow is a multiversal explorer or just incredibly good at manipulating probabilities within our own universe.
Exactly.
But even if it's not proof of parallel realities, Willow's achievement is still groundbreaking, right?
Absolutely. This random distribution benchmark that Willow aced, it's designed to push the limits of what computers can achieve.
Right.
Willow, with its 105 qubits, solved it in under 5 minutes. To put that into perspective, the world's fastest supercomputers would need 10 septillion years, that's a 1 with 24 zeros after it, to arrive at the same answer.
10 septillion years, that's longer than the universe has even existed.
Right.
It makes you wonder, what else could this technology be capable of?
Well, that's where things get even more interesting, because while Willow's achievement is remarkable, it's important to remember that quantum computing is still in its infancy.
So we're just scratching the surface of what's possible.
Exactly, and it's not without its challenges. For example, some critics argue that Willow's success, while impressive, was in solving a very theoretical problem. They're calling for, more tangible real-world applications.
It's like having a supersonic jet that can only fly in a simulator.
Right.
All that power. But where can you actually go with it?
That's a fair point, but remember, every groundbreaking technology faces early skepticism.
Oh, yeah.
The first computers were dismissed as glorified calculators. Look at them now.
Good point. So what's next for quantum computing? What are the hurdles, and what are the potential breakthroughs we might see in the future?
Well, one of the biggest hurdles is scalability.
Okay.
Willow's 105 qubits are impressive, but to tackle truly complex real-world problems, we'll need quantum computers with millions, even billions of qubits, and not just any qubits. They need to be incredibly stable and resistant to errors.
Right, because as you mentioned earlier, quantum systems are notoriously sensitive. The slightest disturbance can throw off calculations. It's like trying to build a house of cards in a hurricane.
Yeah, a very apt analogy. So that's another area where research is focused of developing error correction techniques to make these systems more robust if we can overcome these challenges. The potential applications are simply astounding.
Okay, I'm all ears. What kind of world-changing applications are we talking?
Well, imagine faster drug discovery leading to cures for diseases we thought incurable, or breakthroughs in material science resulting in lighter, stronger, more efficient materials for everything from buildings to spacecraft.
And let's not forget about cybersecurity. If quantum computers can break our current encryption methods, surely they can create new, unbreakable ones, right?
Precisely, quantum cryptography is a field with immense potential, and these are just the applications we can foresee today. The true beauty of scientific breakthroughs is that they often lead to innovations we couldn't even have imagined.
It's like opening a door to a whole new world of possibilities. And speaking of new worlds, what about that multiverse idea? Is there any chance we could actually prove or disprove its existence?
It's a question that's both tantalizing and incredibly complex. Some physicists believe that future experiments with quantum computers might provide insights into the nature of reality itself, potentially offering evidence for or against the multiverse.
So it's not just about faster computers and new materials.
Yeah.
It's about potentially rewriting our understanding of the universe. That's what I love about physics.
Right.
It's always pushing the boundaries of what we thought possible.
It's a constant journey of discovery, and that's what makes this field so captivating.
I couldn't agree more. Before we get too lost in the multiverse, though,
Yeah.
let's bring things back down to Earth for a moment.
Uh,
We've been talking a lot about the science, but what about the people behind it all? I'm curious, what's the culture like in the world of quantum computing research?
It's a fascinating mix of intense competition and intense collaboration, you know?
Wow.
You have these brilliant minds from all over the world working in top universities and tech companies, all racing to make the next breakthrough. But at the same time, there's a strong sense of community and a willingness to share knowledge and ideas.
It's like a high-stakes game with everyone trying to win, but also knowing that the real prize is advancing our understanding of the universe.
Exactly. And there's also a healthy dose of humor and camaraderie. You know, these are people who spend their days grappling with some of the most mind-boggling concepts imaginable.
I bet.
They need a good laugh now and then.
I can imagine. So if someone's listening to this and they're thinking, wow, this quantum computing stuff sounds incredible, I want to learn more, where should they start?
Well, there are some great resources available online and in libraries.
Okay.
You can find introductory courses, articles, and even videos explaining the basics of quantum mechanics and quantum computing. And don't be afraid to dive into the research papers themselves. They can be dense, but they're also where the cutting-edge discoveries are happening.
That's a great tip. And of course, be sure to subscribe to The Deep Dive for more explorations into the fascinating world of science and technology. We'll continue this deep dive into quantum computing in just a moment. But first, a quick message from our sponsors.
Sounds good. So welcome back to Deep Dive Physics. Before the break, we were just discussing the potential of quantum computing.
Right.
And some of the hurdles that researchers are facing. You know, it's a rapidly evolving field.
Yeah.
It seems like every day brings news of another breakthrough or challenge.
It's like watching a scientific thriller unfold in real time.
But speaking of breakthroughs, I've heard rumors about a major update to Google's Gemini AI model.
Okay.
Something called Gemini 2.0 Flash Thinking Expanse 123. It sounds pretty intense.
Doesn't it? The details are still under wraps, but that name, Flash Thinking, suggests like a significant leap in AI's ability to process information and make decisions quickly. You know, it could be a game changer, especially for real-time simulations and like complex problem solving.
I'm starting to see a connection here. Could this flash thinking AI be the key to Google's ambitious world simulation project?
Oh, interesting.
Remember, we touched on their goal of creating an AI that can accurately model the physics of our entire planet? Yeah, you're spot on. If Gemini 2.0 delivers on its promise, it could provide the missing piece for Google's world simulation puzzle.
Okay.
Imagine an AI that can not only understand the laws of physics, but also react and adapt in real time within a simulated environment. It could lead to incredible breakthroughs in our understanding of climate change, weather patterns, even the evolution of life itself.
It's like having a virtual laboratory for testing out different scenarios and seeing how they play out. The possibilities are mind-boggling. But this level of AI sophistication also raises some ethical questions, doesn't it?
Sure.
Who controls this simulated world? What are the implications for privacy and security?
Those are crucial questions, and it's essential to have those conversations as these technologies develop,
Right.
we need to ensure that AI is used responsibly and ethically
Right.
with safeguards in place to prevent misuse and unintended consequences. It's not just about the scientific advancements, it's about the societal impact as well.
Absolutely. We need to consider the ethical implications alongside the scientific ones. But for now, let's bring it back to the practical side of things. Google has announced that AI features will be free for all Workspace subscribers.
Okay.
It's a creepy deal, right?
Yeah, it is. It means that those powerful AI tools, auto-generated spreadsheet designs, meeting summaries, AI-powered note-taking,
Wow.
are now accessible to anyone with a Workspace subscription. Previously, those features came with an extra cost.
It seems like Google is making a strategic move to accelerate AI adoption.
Right.
The more people use these tools, the more data they generate, which can then be used to further refine Google's AI models. Yeah. It's a win-win for them.
Indeed, and Google isn't alone in this push towards AI integration.
Right.
Microsoft is also offering a free version of its Copilot chat for Microsoft 365. It seems we're entering a new era where AI is becoming increasingly embedded in our daily lives, both at work and at home.
It's exciting, but it also makes you wonder what the world will look like in a few years when AI is even more advanced. Do you think we'll ever reach a point where AI surpasses human intelligence?
That's the million-dollar question, and there's no easy answer.
Right.
Some experts believe that artificial general intelligence, or AGI, AI that can perform any intellectual task that a human being can, is just around the corner. Others are more cautious, arguing that we're still a long way from achieving true AGI. It's the debate that will likely continue for many years to come.
It's a fascinating debate and one with profound implications.
Yeah.
But let's bring it back to the topic at hand, Google's quest to build a world simulation. We talk about the potential benefits, but what about the challenges?
Okay.
Creating an AI that can accurately replicate the complexities of our physical world seems like a monumental task.
It is. Think about all the factors involved. Yeah. The laws of physics, the diversity of life, the intricate interactions between different systems. It's a challenge that requires expertise from a wide range of fields, from computer science and physics to biology and even philosophy. It's a massive undertaking, and it's not something that will happen overnight.
It sounds like a project that could take decades, if not centuries, to complete.
It's certainly a long-term endeavor, but even if we don't see a fully realized world simulation in our lifetime, the research and development efforts will undoubtedly lead to significant advancements in other areas.
It's like aiming for the moon and landing among the stars. The journey itself is filled with valuable discovery.
Exactly, and it's important to remember that even if we do achieve this level of simulation,
Right.
it's not a replacement for the real world.
Right.
It's a tool for understanding, for exploration, for testing possibilities.
That's a crucial point. It's not about creating a virtual escape from reality. It's about gaining a deeper understanding of the world we live in and the challenges we face. But let's not forget the ethical considerations. If we create an AI that can simulate our world in such detail, who controls it? And what are the potential consequences if it falls into the wrong hands?
Those are critical questions that need to be addressed from the outset. The development of such powerful AI technologies demands a careful and ethical approach. We need to ensure that there are appropriate safeguards in place to prevent misuse and ensure that the benefits outweigh the risks. It's a responsibility that we can't afford to take lightly.
I couldn't agree more. As we've seen today, the world of AI is full of both incredible promise and potential pitfalls. It's up to us as a society to guide its development in a direction that benefits all of humanity.
Well said, and it's a conversation that needs to involve everyone, not just scientists and engineers.
Absolutely. It's a conversation that needs to happen on a global scale. But for now, let's bring it back to our listeners.
Yeah.
What does all this mean for you, the person listening to this right now?
That's a great question. While it might seem like quantum computing and world simulations are far-off concepts, the truth is they have the potential to impact our lives in profound ways.
For example?
Well, imagine a world where diseases can be diagnosed and treated with unprecedented speed and accuracy thanks to the power of quantum computation.
Okay.
Or a world where new materials with incredible properties are discovered, leading to breakthroughs in energy transportation and countless other industries.
Those are some pretty amazing possibilities. It sounds like we're on the cusp of a technological revolution that could rival the invention of the internet.
It's certainly a possibility, and it's important to remember that we're just at the beginning of this journey. The discoveries being made today are laying the foundation for innovations that we can't even imagine yet.
It's both exciting and a little bit intimidating, isn't it? To think that the world is changing so rapidly, and we're only just beginning to grasp the potential of these emerging technologies.
It's true, but I think it's also a time of incredible opportunity. As we navigate this new landscape, it's crucial that we approach it with a sense of curiosity, open-mindedness, and a willingness to learn and adapt.
I think that's a great message to end on: curiosity, open-mindedness,
Yeah.
and a willingness to learn. Those are the keys to unlocking the potential of the future. And who knows, maybe one day we'll be able to confirm the existence of parallel universes thanks to the power of quantum computing.
Now that would be a deep dive worth taking.
Wow, it has been a wild ride exploring all of this, hasn't it? From qubits and entanglement to the multiverse and world simulations, we've covered a lot of ground today.
Yeah, we have, and it's really a testament to how rapidly these fields are advancing. What seemed like science fiction just a few years ago is now becoming a reality.
It really makes you think, doesn't it, that what wonders will we uncover next? What kind of world will we be living in a decade or even just a few years from now?
Yeah, it's both exciting and a little bit daunting to contemplate, isn't it? But one thing's for sure, staying informed and engaged with these developments is more important than ever.
I wholeheartedly agree, and that's where the deep dive comes in. We're here to break down these complex topics, spark your curiosity, and help you navigate this ever-evolving world of science and technology.
Yeah, it's been a pleasure joining you on this deep dive today.
The pleasure was all mine. And to all our listeners, a huge thank you for joining us on this incredible journey of discovery. If you enjoyed this episode, don't forget to like, subscribe, and share the Deep Dive Physics with your friends. We'll be back soon with another deep dive into the mysteries of the universe. Until then, keep exploring, keep questioning, and keep diving deep.